to understand the molar solution, we have to understand what a mole is. Okay, if you've had a chemistry class, you've had this beat into you a little bit. Now, remember when we talk about, and we use examples of this, when we have a couple, a few, some, a dozen, we have terms that relate to how many of something I have. Okay, well, a mole, not the mammal, that's a biology class, okay, but a mole, in chemistry talk, okay, is a certain number of something. Now, it just so happens, it's huge. This is a huge number of something, because a mole is just a convenient way to say, I got a whole lot of small things, like atoms and molecules. So a mole is 6.02 times 10 to the 23rd of something. Now, if you look at that exponent, 10 to the 23rd, that is huge. So just like a dozen is 12, just like a couple is 2, frequently a few is 3, okay? Unless you're begging your parents for something, then a few you expect a lot more, but you get the idea, okay? So 1 mole is, okay, 6.02 times 10 to the 23rd of something. Could you have a mole of donuts? Okay, great, have a wish? Yeah, we wish. But how many would that be? Be huge. 6.02 times 10 to the 23rd. It's a huge number of donuts. Okay, you can have a mole of anything you want. Okay, now to kind of form a connection, okay, with the periodic table, it just so happens that if you look at each of the elements and you look at their atomic weight that it shows, for example, like oxygen being 15.99 is its atomic weight, and sodium 22.989 being its atomic weight, and hydrogen 1.01 being its atomic weight, it just so happens that that corresponds with, if you had 1 mole of oxygen atoms, you have 15.99 grams. Okay, so if you had 6.023 times 10 to the 23rd oxygen atoms, you have that many grams of oxygen. If you have, okay, 6.023 times 10 to the 23rd sodium atoms, you have that many grams. So on the periodic table, it tells you if you have a mole of this stuff, this is how many grams you've got. So with chlorine, you have 35.37, whatever that number is. That's if you had 6.023 times 10 to the 23rd of those. You have that many grams. And so what that relates to is it relates to our molar solutions, where it's saying, all right, if you have, for example, if I'm referencing, okay, a molar solution, it's how much I have in a given volume, okay, frequently in liters. So if I have 0.14 moles in 1 liter, or with sodium I have 0.004 moles in 1 liter, or excuse me, with potassium, 0.04 moles per liter of potassium. Okay, so you basically take 1 mole of stuff, 6.023 times 10 to the 23rd of stuff, and then you fill it up with water to make a liter. Okay, that's what a molar solution is. And so it tells us, okay, that with salt, for example, if I have a 0.9% solution, that means I have 0.9 grams of salt, okay, in 100 milliliters. And if I want to make a liter of that stuff, I need 1,000 milliliters. So here's your dimensional analysis. So I want to have 1,000 milliliters per liter, and I want to make 1 mole of it. And it just so happens on my periodic table, I take the atomic weight of sodium and I take the atomic weight of chlorine, and I add them together. So that means if I have 6.023 times 10 to the 23rd of salt molecules, I have 58.4 grams of salt molecules. And so that tells me that I have 0.15 moles per liter, a 0.15 molar solution. That's what it tells me. Now, frequently in our body, we don't deal with big volumes and concentrations of stuff. We're small. Okay, so we deal with little volumes. So just like we don't deal a lot with liters, we deal with milliliters. Just like we don't deal a lot with grams, we deal a lot with milligrams. And to go from one to the other, to go from liters to milliliters, to go from grams to milligrams, we simply move the decimal 3 spaces. Well, we do the same thing when we do our molar solutions. So instead of 0.15, because we don't like to deal with decimals, nobody likes to deal with decimals more than we have to. So instead of saying 0.15 moles per liter, couldn't we take that decimal and go, move it 3 spaces? So wouldn't it now be 150 milli? Milli still means what it means, okay? millimoles per liter. So 0.15 moles is the same as 150 millimoles, but we like whole numbers, and so we do that. And so frequently, when you're going to get a report on a patient that shows their sodium level and their potassium level and their magnesium level, we're measuring solutions and we're measuring concentrations. So you're going to get that patient report in millimoles is what you're going to get. How much sodium does the patient have? How much potassium does the patient have? So this stuff we're learning, you may feel like it's okay, like you're in a math class. You know, when am I going to ever use this again? Well, okay, if you're doing, excuse me, if you're working at all with patients, every day, okay, every shift, every half a shift, you're going to use it all the time, okay. So the better you know it, okay, the better off you'll be. And so there's where you can see the relationship in the table from your book, the relationship of our percent solutions, how much per given volume, and our molar solution is how much in moles per given volume. So the difference being with our percentage, it's grams per 100 milliliters. In our molar solutions, it's moles per liter. So there's the relationships of our amount and volume.